Right, so you guys asked for 2.2.2. Let's go through that one quickly. Um, okay, so the first thing that we're going to do here is this thing on the right hand side. Let's take it over to our left hand side. So we're going to subtract both sides with that term. So we will have 4 to the power of x plus 8. Or, well, let's leave it like that for now. Minus 9 times 2 to the power of x. All of this equals to 0. Right, so this is what we need to solve. Next, what we're going to do is this 4 that we have over here. Let's go and change it to a prime base. Okay, so we're going to change that to 2 squared, and that is going to be to the power of x, right? I'm just going to put this last term, I'm going to make it second. So I'm going to say minus 9 times 2 to the power of x plus our 8. All of this is equal to 0. You'll see why I want to do that in a second. So the next thing that we're going to do, so obviously these are going to multiply together. So it's going to become, so what I'm going to do is I'm going to leave it as 2 to the power of x, and I'm going to leave that squared like you see over there, and then I'm going to have minus 9 times 2 to the power of x. So we didn't do any math in that step. We just rewrote that because the x and the 2, they're multiplying, and the order of multiplication doesn't matter. So the fact that I swap them doesn't change anything. It just helps me. It helps me identify something. So what I'm going to do now is I see that this thing is over here and over here. So I'm going to replace 2x. And from now on, in this question, this guy's name is going to be k. So what do I have above? I have k, and k is being squared. Then I have minus 9, and I have my k. And then I have this plus 8 equals to 0, and this is nice. That's easy. That's a basic trinomial, so we can go with our two sets of brackets. Equals 0. In this case, it's going to be k and k, not x and x. K and k. And we are looking for the factors of 8. So what are the factors of 8? Let's maybe put it over here. Factors of 8 is going to be 1 and 8, 2 and 4, right? And that's all of them. Which of those pairings can get me the negative 9 that I've got? The 1 and the 8. If I subtract both of them, that will give me a 9, a negative 9. So it's going to be a 1 and a 8. Because we know that this is going to be a positive, our signs are the same, and the negative over here tells me that both of these signs will be negative. Okay, great. So I've got that. This generates a solution. This generates a solution. So we are going to say that k, let's say minus 1, let's not skip any steps, equals to 0. We add 1 on both sides, so k is equal to 1. And okay, I just want to keep k in a different color so that we remember that k wasn't in our original question. On the side on here is k minus 8 is equal to 0. So we are going to take the negative 8 over. We're adding 8 on both sides. So we end up with k is equal to positive 8. Okay, great. So we have these two. However, if we look back at this year, we realize that we don't actually have a k in our question. So we need to go change k, and we're going to change it back to 2 to the power of x. So here we have 2 to the power of x equals 1. And on the side, we have 2 to the power of x equals 8. Equals 8. Great. So what we do at this point, we need to solve these two. What we want to create is we want same bases. The reason we want same bases, because if your bases are the same, your exponents will be equal. So our 1 that we have over here, we're going to replace it with something that's still equal to 1. So we're going to say 2 to the power of x is equal to 2 to the power of 0, because anything to the power of 0 is still 1. So what we've created was we have same bases. Okay, so this is a base 2, this is a base 2. Now what we're going to say is because the bases are the same, the exponents are equal. So the exponents don't disappear, they don't cancel out, they don't divide, right? Don't do any weird stuff like that. But because our bases are the same, whatever our exponents will be, they have to equal to each other. So now we'll say therefore x is equal to 0. Okay, let's do the one on this side. 2 to the power of x. We're going to replace the 8 with something that is still 8. and that's going to be 2 to the power of 3. Again, same as what we said, because our bases are the same, our exponents will be equal. So here we will say that the x is equal to the 3, and that's that.